This next video will entail instructions on how to service the unit, including removing the drive motor, replacing elements, troubleshooting element issues and drive issues. Prior to working on the unit, you need to unplug the cord and remove the cover. The cover is held on by 6 screws on the bottom and 4 screws on the back. Once the cover is removed, you can go ahead and plug the power back in, being careful not to have anything touching live wires, and power the unit back up. During the preheat stage, you can check the amp draw on all the elements to make sure that each element is drawing about the same amount of amperage. What I've got to do that is a Sperry amp meter with a adjustable dial, which I can range through the amp draws with these elements. I've got it set on the lowest amp scale, which goes up to 6. It's kind of nice. It's an analog meter. It gives you a pretty quick indication of what's going on. So we'll go ahead and clamp it on, make sure we have the same amp draw across all the elements quickly. Okay, we're drawing about 2.6 amps. That element, we're drawing 2.7 amps on that element, 2.6 amps on that element, 2.5 amps on that element, and we're 2.8 amps on that element, and 2.8 amps on that element. So they're all relatively in the same area, so that's how you can check quickly to see if you have power going through all the elements and if the amp draw is the same. That's a good indication of, no power to the elements. If you're grounding on one part but not the other part, you want to check the amp draw, and that'll quickly tell you if you got elements out or if you got burned wires, something of that nature. Okay, to troubleshoot the drive motor to see if we have power, this one obviously we got power. We can see the motor turning here, but in cases where you don't have the motor turning, what you're going to have to do is you're going to have to take your meter and you're going to put your leads on M1 on the board and M2 on the board. M1 is down on this terminal, and we're going to find on this board we got M2 marked here. It's going to be this bottom connector, and as you can see we got 241 volts. I've got it hooked to a 240 volt system, so we know we have power coming out of the board going to the motor. The motor is still not turning and we have that power applied, and we know that that motor is bound up. Either something's jammed in the top or the motor itself is bad and we want to replace the motor. If we don't have any power coming out of the board and it's in the toast mode or one of the product modes, and we know that we have a problem, with the power board sending power out to the motor. One more thing to remember when you're troubleshooting a drive motor problem is sometimes you'll get to the unit and the unit's going to give you a temporary reading and the motor's not going to turn. It's going to appear that you've got a problem with the temp sensor. Well, this unit doesn't use a temp sensor, and what we do is we monitor voltage through the resettable high limit. If the high limit is not tripped and you're getting a temp error, then we have something going on with the control circuit. One way you can easily troubleshoot a seemingly bad motor in that situation is put the unit into cool down. In the cool down mode, we automatically turn on the fan, the cooling fan, and the motor. You will see the motor begin to turn and the cooling fan will come on. That's an indication that we have a good motor and we're really looking at a bad control board. If indeed you can get the motor to run, the motor's good and you have voltage applied through the power board, so you know that there's something going on with the control board. Okay, let's say you get to the location and what you see on the screen is you see temp error. When you first get there and you're troubleshooting a temp error, one thing you're going to want to do is unplug the unit, take the cover off, and then plug the unit back in. When you plug it back in, it should say off. When you press the button, chances are it will go back into temp error. You want to take your meter leads and you want to check for voltage at the board. So we're going to go to L1 on the board on the bottom. If I can get down there, and L2 over on the other side. And yeah, this is a little more difficult than it looks here. Okay, and across those two, we should get 240 volts. If you have 240 volts there, you know that your high limit's good because that's what supplies the voltage to L1 and L2. What you want to do then is once it's showing temp error, go ahead and push the cool down button. If the cool down, it goes into cool down, and then the conveyor starts to turn again, and the fan starts back up, then you know that your power board's good, and you're more than likely looking at a bad button board or control board up in the front that's created your temp error. If you're probing on the board, you don't have that 240 volts, then you're looking at your high limit. What you can do to see if it's the high limit is turn the unit off, unplug it from the wall, and you want to check for continuity through your high limit switch. That'll tell you if you got a problem. The high limit's a fairly common part. We use it in all of the units. It's part number 2E200566. We use it on all the conveyor toasters. Okay, another thing to go along with temp error is if the high limit is tripped, and that's all you find, that is most commonly caused by something getting sucked up into the fan. The fan is located on the bottom of the unit. You want to make sure that the screen is clean and the air is being blown into the unit. That's what cools it down. That high limit is just to keep the temperature cool in that control compartment where that power board is located and that wire is going up to the control board. If that gets plugged up on the bottom of the unit, or for some reason the fan quits, then you know that you've got a problem down there with air circulating, and you need to fix the fan. One of the other things that happens with these units is the customer will sometimes turn the units off before it's completed a cool down, and in that case what will happen is that high limit will trip because it will heat up too high in the compartment on the side of the unit, just like if the fan was plugged, and it will cause it to go into temp error the next time they start it up. Alright, once I get the wires hooked back up on both terminal blocks, then I go ahead and I attach new tie wraps, and we're good to go. Alright, let's say that we have a bad high limit. We've tried pressing the high limit, it won't reset. We checked across the two terminal leads, and we're still not able to sense any continuity through it. All we need to do is take off these two Phillips screws. We take the high limit out, we put the new high limit in, screw it back in, and reattach the wires. Let's move down to the drive motor. If we want to replace the drive motor, what we have to do is we have to remove the upper gear, which is held on with a little Allen screw. So we take the upper gear off, which allows us to drop the chain off. And we take the lower gear off, which is held on with a drive set screw also. That allows us to get to the Phillips screws. We take the Phillips screws loose. So we remove the Phillips screws. The drive motor comes out the back, just like so. The drive motor's got a black wire, a white wire, and a blue wire. From the factory it comes with the black and white wire untaped and the blue wire taped. The combination is black and white is for 208. black and blue is for 240. When you get your new one, go ahead and reattach the wires, you know, according to your voltage. You want to put your drive motor back in the unit, and you want to reinstall it just the way I took it out. Once you get all your screws reattached, go ahead and slip your drive gear back on your motor. You want to take your drive sprocket up on the top. Actually, you want to put this around down here first. So you can put it on, and you want to attach this up on the top. So you put that on. And let's get it rolled around so screw in the flat spot. Let the motor go back down all by itself, and then we tighten down the set screws. Once you get your set screws tightened, then you go ahead and you tighten your motor back up. What you want in the chain is you want about 1/4 inch of deflection. Because if you get on there too tight, it's going to wear your motor out too quick. And that's all there is for changing the motor. One of the harder things to do, I think, is to change the front button board. And it's not hard, it's just a little cumbersome because of the way it's positioned. What you want to do to change that out, if you've diagnosed it and figured that that is wrong, is you want to remove the screws in the back. What I'm doing here is I'm showing you where the screws are. There's the button board mounted against the front plate. There's one screw down there. There's a second screw up there. And as we go up, there's a third screw. And I believe there's a fourth screw when we get up here towards the top. And that's what holds that button board on. Like I said, it's just that you have to use a pocket screwdriver. You can't over tighten it. It's a little tough to get in there with your hands, but it's, you know, a 15-minute job. It's definitely easier to do when the oven is cooled down. Okay. Something else that we frequently get calls on conveyor toasters, not necessarily just this style QCSE2-600HW, is regarding the conveyor belt. You know, how much slack should be in a conveyor belt. If a conveyor belt is adjusted properly, what you're going to get is at the entrance to the oven, you're going to be able to lift that belt up about 3/4 of an inch. That's all the slack you really want in it. If you have any more slack in it, what's going to happen is it's going to hang up and drag in areas. It's going to squeak on the top a lot of times. It'll also allow these bearings to push further out than they should be. This bar in the front is spring-loaded, and that's what actually keeps tension on that chain. If you get more slack in there than that, then it's just going to be free-floating and create issues. Something you have to do is, if there's a lot of slack in the chain, you can actually remove links and put it back together. If the chain is excessively stretched and you see it binding a lot and riding up on the gears on the front of these rollers, then what you have to do is replace that conveyor belt. That pretty much wraps up the troubleshooting on this toaster. It's really not very difficult. The electronics are a little overwhelming if you're not used to working with electronics, but the more you work on them, the quicker you get at fixing the units. Thanks for checking out the website.